Welcome back. All right, so by now you know DeFi is built on decentralized blockchains. But how exactly? What is the DeFi stack? Let's dive into it. So the DeFi stack is, if you look at this picture here, at this graph here, is really like a intertwined ecosystem of a settlement layer where we have a blockchain that can be, for instance, an Ethereum blockchain or any EVM-based blockchain or any like smart contract-enabled blockchain, which on top of it has an asset layer that's typically highly intertwined through a native protocol asset. So Ether is an example, but there may be many others. And then we have so-called fungible and non-fungible tokens. An example of a fungible token is an ERC20. That's a token that you can send and receive. You can divide it almost as much as you want, while a non-fungible token is a token that you typically cannot divide unless you create a derivative of it, which you can do on the protocol layer, which is one layer on top of this. So where you have the exchange, lending, derivatives, and asset management applications. So these are different protocols or underlying concepts, financial concepts that are then put into place by an application. So you have, for example, multiple applications, multiple dexes, right? You have like Uniswap and SushiSwap and UtsuSwap or different types of swap exchanges on the application layer, which can then again be aggregated on the aggregation layer. So you can actually aggregate multiple AMMs. For example, there's 1inch or Paraswap that are off-chain aggregators. You can also have on-chain aggregators. I have published a paper on A2MM, which is an on-chain aggregator of multiple AMMs. So this is really the entire protocol stack if you look at DeFi. And there are users, right? The users are those that have a particular account, like an address, which is governed by a private key. So a public key is the address, while the private key is an address that allows a user to sign and send a transaction. And the protocols, they're obviously designed and implemented in a smart contract language where users can also partake in governance activities based on the stake or the voting power that they hold. And maybe an alternative way of looking at the DeFi stack is the following. So you can think of having here a distributed database with an atomic settlement. So what's important is that there are a variety of elements. So here you have the information propagation network. That's, for example, a peer-to-peer layer. And then you do have a consensus layer, which is the blockchain. And then you have an application or logic state on top of it. And this kind of architecture really is a distributed database. When I mean atomic settlement, what I mean is if this atomicity property, you will actually encounter this several times in our lecture. Atomicity refers to a transaction executing either in its entirety or failing completely. Meaning, if a transaction, so if you have a transaction here, TX, and it does action A, B, and C, so the atomicity property would guarantee that all the three actions are being executed or none of them are, right? So if B fails, A and C will fail as well. Then we have a variety of DeFi services that also take advantage of this atomic composability. So we have exchanges, lending, borrowing, flash loans, market making, insurance, etc. And they all rely on well-defined and widely adopted asset standards, such as a native coin or fungible tokens and non-fungible tokens, similar to the previous architecture that I've shown you. What's interesting is when you basically deploy such a financial ecosystem, then you automatically get so-called market mechanisms, right? Because these different exchanges and lending and borrowing platforms, they have different markets. So a market is, for example, an asset A and B. And if you have another market with also asset A and B, but this is another market, then the price differences between those markets needs to be synchronized, and this is what's happening through arbitrage. So arbitrage is a benign method to synchronize a variety of markets. If you perform liquidations, lending and borrowing, so if you borrow something, then there's the risk that there's a liquidation event, and the same on the blockchain. So it's quite analogous to the traditional finance domain, I would say. We mentioned governance a few times already. Security deposits can also happen, for example, for governance processes. You need to provide a deposit before you can vote. And so now we get to the juicy part, because this ecosystem is mostly unregulated compared to CeFi. In DeFi, we can basically re-experience an entire variety of different market manipulation techniques, ranging from front, back running, to pump and dump schemes, wash trading, market cornering, bear rating, and many others. And these are, people are really flexible in doing whatever they want, and it's sometimes quite unclear whether something is unlawful because it's not being regulated at all. It's also questionable whether some actions are ethical or unethical, so I'll let you be the judge of it. But you can really, currently in DeFi, it's so new that this is really, there's so many low-hanging fruits for you to venture into any of these market manipulations if you'd like to explore this. That's really the kind of the playground where my PhD students are having fun writing papers about a variety of different techniques that can be done, and also how to protect against those, right? So it's, at the end of the day, we want DeFi to remain as or to become more secure than the DeFi from yesterday. So we need to understand the attacks and then build and develop measures to protect users and protocols against market manipulations. So the high-level service architecture of DeFi can also be visualized as such, as we have done in a CeFi DeFi paper. So you can see here how CeFi and DeFi actually are rather intertwined, I think in particular through so-called stablecoins. So we will discuss stablecoins in a bit more in the later slides, but basically a stablecoin is a coin that tries to be more stable than volatile cryptocurrencies. And you can see here their Tether, USDT, and USDC. So these are two so-called stable US dollar backed stablecoins. They are rather well regulated, and they're highly intertwined in DeFi with billions of US dollar of issued stablecoins. And then these assets naturally flow into leveraged loans, they flow into automated market makers, they flow into lending and borrowing, and the lending and borrowing platforms must use oracles to understand their price settings. So this is really like a already quite intertwined ecosystem. And we may discuss this later, but typically regulators already have some kind of power on DeFi. For example, USDC and USDT can actually censor some of their assets. So your address, if you hold USDC or USDT, your address can land on a blacklist. If your address is blacklisted, then you can no longer move your assets. And USDT even has the possibility to destroy your funds. So they literally can burn your money without you doing anything against it. So here you might actually say, well, is this at all DeFi? I mean, if you look back at our decision tree, that doesn't look that much to be, that doesn't look that familiar to DeFi, right? I mean, in DeFi, we thought we would have a non-custodial system where we are the custodians of the coins, and that's rather a bit questionable here on that end. So I hope this gave you a good understanding of the DeFi stack. I hope you also understand that DeFi is already rather intertwined with CeFi, maybe to the surprise of some. Some DeFi protocols can censor or even destroy your funds, so be aware. We're looking forward for this entire ecosystem to really merge even further together.